All right, and we are now going live. So hello and thank everyone who's going to be joining us tonight. My name is LaJoy Royston, and I am the program director for Trey Athletes. We are a Dallas-based nonprofit whose mission is to empower athletes to be leaders, role models, and influential voices for their communities. Our leadership development program serves high school basketball players and their families from over 40 zip codes across Dallas. Our Trey athletes are headed to play basketball at colleges and universities across the country, and they work hard every day to be leaders on and off the court. Tonight, I have joining me Mr. Drew Dudley, who is a structural engineer and also a professor of architecture at Texas A&M University. Hello, Drew. Thank you so much for joining us for this virtual job shadow. I know you're going to have so much that you can provide us about your background, also your experience playing football at Kansas. So with that, we're going to go ahead and get started. And Drew, kicking off to you, tell us about yourself. Where are you from, where you grew up, all that good stuff.
All right. Hi, LaJoy, and thanks for that introduction. So, yeah, Drew Dudley. I am from College Station, Texas. Went and played football at the University of Kansas, and I always have to preface that was when Kansas was ranked number 2 in the country and won the BCS Orange Bowl, because Kansas is known as a basketball school, which they did overshadow us that year because the same year that we won the BCS Orange Bowl, they won the national championship. But it was a great time to be at Kansas. It was a lot of fun. So after Kansas, I had a 1-week stint in the NFL. Had some health issues. They cut me there, and that's when I decided to really focus on my academics. I went and got my master's at Texas A&M in engineering, and then I worked in Houston for 4 years. And then about 3.5 years ago, I started my own company. And so now we've got 16 employees based out of Bryan College Station, Texas, and we do projects all over the country.
Very, very nice. Like you just gave a very cool picture of like your timeline and your story of how you played football in college. You went to the NFL. Congratulations on that. A lot of people don't make it that far. And then you went on to be engineering, and congrats on having your own company, being an entrepreneur as well. I want to take us back. We're going to rewind back to your days as an athlete. So you played football at Kansas, which is a Division I school. Tell us about your trajectory of getting it up to that point. When did you start playing football? Did you have your laser vision set on going to NFL? What was that experience like for you as a football player?
Yeah, to me, that's a pretty good story, too. So I changed high schools my freshman year. We moved to a different city. So my freshman year coming in, I didn't know anybody. I was a decent athlete at that time, but I kind of hit my growth spurt late. So even going into my sophomore year, I was on the B team. And most of that was because I also played quarterback, and I was a terrible quarterback, but I was a really good linebacker. So I remember I was pretty downtrodden my sophomore year when they put me on the B team. And I remember my dad, I specifically remember the conversation. He said, the only person that's going to stop you from playing college football is you. Basically saying, if you want to get there, you're going to have to put in the work, in the weight room, in the summer workouts. So basically I went from my sophomore year, I was probably about 140. And at the start of my junior year, I weighed 210 pounds, made all state that year, made all state my senior year. And then that's when the offers came. So it's kind of, to me, it was a big success story because, like I said, I was very disheartened when I made the B team my sophomore year, and then turned around and made all state with varsity the next year.
Wow.
I had offers. I had offers from Oklahoma State and Tech and Baylor and Kansas State and Kansas and Stanford and Duke.
Wow.
And ultimately, I committed to Oklahoma State, but I don't know if they still do it. But at that time, they were kind of known for offering a whole bunch of people. And they ended up having like 4 other linebackers commit the same year. So that's when I started looking at other places, and I kind of landed on Kansas. And it worked out good. Like I said, we had a great year, and it was a lot of fun playing there. So that was kind of the transition on how I got to college football. But yes, growing up, I always wanted to play college football. In fact, I loved basketball too, and I know these are all basketball. I quit basketball after my sophomore year because I would lose too much weight. That's basketball season, I would always lose like 20 pounds because all the running that we were doing, and I wanted to focus on football. And my dad, I remember even then, told me, "You're going to regret quitting it," and I do to this day. Yeah, I go, I wish I had kept playing basketball because I love playing.
Okay. Nice. So, talk to us about then when you graduated, you left Kansas and you went to the NFL and then you got cut. Did you have a backup plan for if the NFL didn't work out for you?
Yeah, I did. I mean, it was kind of unconventional that I was undergrad in civil engineering to begin with. Like I was one of two that had gone through the civil engineering department from the football team in the last 3 or 4 years. So it was rare. So I guess I say I always had that backup plan, and they
Okay.
do hit you with it. When we were at Kansas, they're always telling us, none of you are going to stay in the NFL forever. My roommate was Chris Harris, who a lot of you probably know Chris Harris because he's been in the Pro Bowl like 5 or 6 times. He just made the All-Decade team. He played for the Denver Broncos. Now he's on the Chargers. Chris Harris was one. Kansas was his only football scholarship offer that he had. And then he was undrafted coming out, and he got undrafted pickup by the Broncos and ended up making the Pro Bowl his second year of the NFL. But so even him, like he was focused on his education. But
Yeah.
another guy I played with, you may know the name, is Aqib Talib. So he's a pretty big star in the NFL. And in fact, we just had a 10-year Orange Bowl reunion that we did a Zoom session very similar to this. And Aqib's about to retire, and he's talking to Todd Reesing, our quarterback, and other people who are more in like the investment side, like, hey, I'm ready to move on to the second part of my career. Even he did it. Like he's going to be in the Hall of Fame, but even he knows that there's something after football, after sports, because you're not going to play till you're 50.
Yeah, that's true. Very, very nice segue then. I like to talk about it because you just said that you were one of two football players who went through the engineering program over like a 3 or 4 year period. Why was that so rare for football players to do that program?
I mean, it's hard. It's a hard major to get into. In fact, I remember they tried to talk me out of it. My athletic advisors tried to talk me out of it multiple times because, one, it requires more hours than some of the other majors. So I think I had to have 132 undergraduate hours, where most of them are around like 124. So there are more hours. They're more demanding, and just the athletic department isn't set up for it. So when you get into it, they'll have tutors for pretty much all your classes, and they require everybody go through tutoring the first year. But they let me out after the first month because they didn't have tutors that did the classes I was
Okay.
in. But yeah, and I think the bigger part, and we'll kind of get into this too, I think the reason it's rare is I think most student athletes aren't even aware of those majors.
Okay.
Um, so that's kind of what we're trying to get out in the architecture and engineering profession is what we do, because we need more people, especially in the United States, to join our profession because we're low on numbers right now.
Yeah. How did you manage then like the additional hours you had to do and then also the demanding schedule you had as an athlete as well?
Yes, I won't say it's easy, and I in college and still today, I take a lot of offense to people who call it a free ride. Like you went on scholarship on a free ride, you went to college on a free ride. Like, well, if you count working 60 hours a week, a free ride, because that's what college sports is. Football, I mean, basketball, you're going to be traveling a lot, but football is demanding. You don't have a lot of travel games, but your film and workout and training sessions, you definitely have to be able to manage your time and devote those hours. So you're not going to get to go out and party as much as normal college kids do but you got to set your priorities. But I'll also say that most of your professors, at least in my experience, were very eager to help me. So the example I'll give is in the fall. Two of my professors, they would give like Saturday help sessions, like special sessions that people could come up and ask questions. Obviously, I couldn't go on Saturdays because that was game day. So
Mhm.
they would hold special sessions for me on Sunday, one-on-one. I would just sit down with these professors and they would let me ask my questions. Because they were excited that there was a football player in the department as a rare thing. So they were willing to go out of their way. Now, they weren't giving me grades, but they were definitely there to help me learn.
Right, that's nice, but you had to take advantage of that. So, because
Yes.
even though you spent Saturday, you had to game, you're probably tired from all of that, then you have to get up on Sunday and go to this additional study session to get this additional help for your classes. So it
Right.
sounds like you were willing to put in, like you said, to devote those hours and set your priorities. It was something you really wanted to do because it
Yeah.
wasn't easy for you.
No, it's not. It's definitely not easy. College sports is not easy. It's a job on top of it, but it is so rewarding. So it's, the trials and tribulations that you go through with your teammates will make you brothers for life. So that's kind of a unique aspect to it. It's like a fraternity, but I would say even tenfold compared to fraternity, because how much time we spend to each other, the hard times that you have to go through with each other. It's a bond that is pretty special, and that was kind of invoked when we did that 10-year Orange Bowl reunion. Some of these guys I haven't seen in 7-8 years, but immediately it's like we're all back in the locker room making fun of each other. And everyone's having fun, but it was a good time.
Nice. Okay. Well, thank you for sharing that experience about your about playing and then getting into the NFL and managing being a football player and then having that hard major of being an engineering major as well. So talk me through once you left the NFL and then you said you went and you got your master's degree. Talk us about from that point to now and what that looks like as far as your career. Walk us through that.
And so it's kind of so in structural engineering. So I'm a structural engineer. In our field, we work for architects. So usually, let's say that you want to build a new commercial building. You own a business. You want to build a building. You're usually going to go hire the architect first, and the architect is the one that's going to draw up the pretty plans. Like, this is what the building is going to look like. The structural engineer, we make sure that building doesn't fall down. So whenever a hurricane or an earthquake happens, or you've got a bunch of people jumping in a stadium, we make sure that that structure does not fall down. But in structural engineering today, all the bigger companies require you to have a master's. So I kind of knew that going in. So that's why I was determined that I was going to go get my master's, because I wanted to work at the big companies. And so the company that I worked for coming out of my master's degree, it's called Walter P. Moore, but they're the structural engineer for Dallas Cowboys Stadium, for Reliance Stadium, or NRG, where the Texans play. I got to work on Kyle Field at Texas A&M, which is kind of a dream project because that's my hometown. And I'm followed the Aggies my whole life. But yeah, so coming out of there, I worked at that big firm in Houston, doing a lot of sports design like that. But yeah, that's kind of how I got there, and that's why I went after my master's. It's kind of just the nature of the industry that structural engineering right now, pretty much everyone goes and gets a master's.
Okay. So did you know, because like it sounds like you had like some background knowledge. How did you find out about the field of engineering and that was something that you wanted to get into?
So my dad is a general contractor. So
Wow.
my dad builds buildings. So in fact, when I was first going into college, I thought I might want to follow in my dad's footsteps and build buildings. But as I got into my classes, I kind of determined I'd prefer to be on the design side. Not the one that's out there responsible for building it, but designing it, make sure it stands up. To me, that was kind of drawn to it when I was going. But I did have the advantage of I knew what the industry was. Like, I knew what a structural engineer did. I knew what an architect did because I had worked for my dad growing up in the summers. Uh,
Nice.
and we mentioned this earlier, but so that there is a program called ACE Mentor we talked about. So it tries to mentor high school students about architecture, construction, engineering. Just tell them about what these do in these professions, because most people, if you don't have a parent or a family member connected to that industry, don't know what we do. We talk about there's no TV shows about structural engineers except the one we talked, Prison Break. Is the only show that I know of that there's a structural engineer, and the only reason they showed him is because he got into prison to help break his brother out because he was an engineer for the jail, so he knew the weak spots and how to get out.
So it's nice that I'm happy you brought that up because that would be my next question about how do young people get more exposure to engineering in that field. And ACE Mentor, it sounds like it's exactly there for that reason, to get young people exposed to different kinds of jobs and careers, and in particular with architecture, construction, and engineering. Nice.
Yeah.
Okay. All right. A few more questions for you, sir. So you knew you were going to be in this field because of the work that your dad did. Um, Tell me what your favorite thing is about the work that you do right now.
Hmm. Well, this is another thing that this is more about careers in general, but when you're getting your education, you kind of focus on the technical stuff. And what you'll learn when you get out in the industry is, regardless of the industry that you go into, what really matters is, can you manage people? Can you lead people? and basically, do you get along with people? So
Mhm.
regardless of what industry you go in, your people skills are going to be huge. So in our world, we'll call it business development. Are you able to do business development? Like, are you able to go talk to architects and convince them that they can trust you with their projects? Same thing with contractors. So what I would say is the thing that I enjoy most about where I'm at now is because I've got 16 employees is managing and leading those folks. The technical stuff as kind of you move up the career ladder becomes less important. You've got to have those fundamentals, but it's really the people skills that are what differentiate you from other folks.
Okay. And so you like working with people then. That's something that you enjoy and like that's your favorite part of what you do.
I do. I'm naturally an introvert, but I do like when I'm around my people, like people that I know. I do like I do like feed off of other people's attitude. I like the Corona stuff, having to work from home. Like that was fun for a couple of days, but then after a while, it's like, all right, I'd like to see people again.
I think that's how everybody's feeling, whether you're introvert or extrovert. It's kind of like, all right, we've been doing this long enough. We need to be around some other folks then.
Yeah.
So then what's your least favorite thing about your work?
So you may or may not have heard about this, but it was about 6 months ago. There was a Hard Rock casino in New Orleans that collapsed and killed 3 of the construction workers.
Mm,
So I guess what I would say, our job has real consequences if we mess up.
yeah.
So that was a bad design, ended up killing people. So what I would say is it's always in the back of our mind that, listen, if we mess up, that you could have life safety issues on your hand. And the one that we are taught in college, which happened back in the 90s, is the Hyatt Kansas City bridge collapse. So it was a Hyatt hotel in Kansas City, and they had this sky bridge. So have you ever been in like an Embassy Suites where they
Yeah.
have this
Have like two sides or something and they'll have the bridge connecting them.
yeah, so they had this bridge that went across that courtyard, and they were having a party on it, and it collapsed and killed 88 people.
Oh wow.
So I would say, like, I'm not really concerned about it because we do a good job. We have quality control measures in place to make sure that that doesn't happen. But I would say that the threat that if we do make a mistake, it has. I mean, same as a doctor, right? If a doctor messes up, it could have percussions on people's lives. Same thing with us. If we don't do a design correctly, it could have an impact on people's lives.
That's it's really interesting. I never thought about that. I'm originally from Chicago, and a lot of buildings have like back porches that, and people will build them. And like I guess like buildings have codes you're supposed to follow, right? And I guess part of that has to do with making sure that it's structurally sound, working with the engineer. So if someone goes and builds something like I'm gonna just build this, and they don't
Yeah.
get it checked off with anyone, the fact that they're not checking it with anyone, someone like a structural engineer to make sure that it's structurally sound, is why those kind of things mess up or break or fall or collapse.
Yep. Yep.
Wow.
In fact, that's why, like, in the state of Texas, the reason that we have professional engineers, so that we are required by law on certain types of projects. Now, single family homes, kind of like you were talking about, a lot of those don't require an engineer to be involved. But if you're doing a commercial building, let's say you're building a school, yes, you do have to have a professional engineer involved. That goes back, it was called the New London disaster, but there's a town in Texas called New London that I think it was in the 1940s. They had a gas leak because the gas was installed wrong, and the school blew up, killed 242 students and teachers. And
Wow.
that's when they passed the Texas Engineering Practice Act, which requires professional engineers on those type of projects. So yeah, it can
Wow.
have real consequences.
I'm gaining like having so much more respect for engineers and the work that you do to protect everybody and make sure that we're safe when we're going into these big buildings, and the fact that we can be on like a rooftop of a building and it's okay for us to be having this party and knowing nothing bad is going to happen. So I never
Yep.
even thought that you're saving lives with the work that you do, which
Yeah,
is
and we have to balance it because you can go on the far side and be way too conservative. But if you're way too conservative, then you're going to make that building too expensive. So we're balancing the cost with at the baseline we got to make it safe, but we're trying to also make it as cost efficient as possible. Otherwise, everyone's home is more expensive. Prices would go up on everything. So you got to balance those two.
very delicate line you have to walk in.
Well, I'll give you an example of that balance. So Dallas area, you're familiar with tornadoes, right? So
I you guys have a lot of tornadoes in Dallas?
tornadoes have been a hot topic in Dallas lately. In fact, one hit less than a year ago that caused quite a bit of damage near downtown Dallas. But the building code as it currently stands, we do not design for tornadoes.
Mm.
And the reason is because one, they're so rare and the occurrence of them is so rare, like where they actually hit a populated area, but also it would make our building designs get 10 times more expensive if we designed that it would withstand a tornado hit. So right now, that's a common misconception. We design for hurricanes and earthquakes. We do not design for tornadoes right now per the building code.
Is that something that's changing then because like more tornadoes have been happening there? Because you said it's a hot topic right now.
Not the whole building. What did change is in Dallas now they require that all buildings like schools and Home Depots and stuff like that have tornado shelters in it. So the whole
Okay.
building is not going to be designed for it, but they will have a designated tornado shelter place in the building.
Okay. Well, that's a nice way to change it, like you said, to meet that to walk that line of making it not super expensive, but still making sure people can be safe.
Right.
That works out then. Wow, so much, like there's so many things that like go into the work that you do that I never would have thought. I'm just thinking structural engineer because I'm thinking about HGTV and they're doing house flips or something and they have to call the engineer and see if they can take out the beam or not in the kitchen. But it's like so much more than that.
Yeah.
I'm learning a lot here and it's really fascinating to me.
Yeah.
Um,
And I'll speak about architecture too, because I know that was part of the topic. So
yeah,
I'm not an architect, but I've taught in the college architecture and I work with architects every day. So what you may not know that architects do, so we all know that architects draw the pretty pictures,
yeah,
right? They make the building pretty, but what they do for the building code, because the building code doesn't say you have to make your building pretty. What the building code for the architect says is it has to have enough egress if there's a fire. So if you're in a 30-story building, there you have to be able to get that building has to withstand to be able to stand up in a fire for 2 hours to allow everyone to evacuate. So that's for the architects. They got to make sure that there's enough exit doors, stairs, that people can get out of that building when there's a fire. They also have to make sure that the building is ADA compliant. So if you're in a wheelchair, they have to make sure all the ramps and doorways are accessible to a wheelchair. Even down to like the handrails in the restroom, those have to be designed. That kind of gets into structural too. Those handrails in the bathroom have to be designed to support a 200-pound load. So if somebody is leaning on it, it doesn't break on them and then they get injured. What else do architects do? So a lot of the biggest building code stuff that they do is really have to do with fire code. Um, and that again, that stems from historical events. So in I think it was 1903, Chicago had a fire which
yep.
destroyed the
Great
entire city.
Chicago fire,
Yeah,
which was
burnt down the whole city.
cow, which was not true. Cow, it's a big thing in Chicago.
Okay, so you're giving me inside knowledge. I didn't know that.
Well, I'm from Chicago, so we know about the Great Chicago Fire. Yeah,
Yeah.
it was started by some lady named Miss O'Leary's cow knocked over a lantern, and her family ended up suing because like that's not what happened. You know what happened. Yeah.
But so yeah, what the architects do is part of their requirement is to make sure that that doesn't happen again. That the building, if you have buildings really close to each other, they're supposed to be built with fireproof materials so that fire won't pass over easily to the next building.
Mm-hmm.
And also, it's supposed to slow down the burn within the building so that people can get out and isolate the fire to a certain location. So that's a lot of what architects do. They're not all about making buildings pretty. They do have some functional life safety requirements as well.
But I guess that kind of requires like a certain level of creativity though, because, as an architect, you're given these requirements and like all these things you have to design within these confines, right? So they have to make sure, like you said, the materials they have to use, making sure a certain number of stairs they have to have, all these things, and they have to still make it pretty, even still with all these requirements as well. So I didn't even know that they had to take that stuff into account when they're drawing up or coming up with these plans for different buildings and houses and stuff.
Yeah.
Very fascinating work. So, I guess I'd like to know, because you do a few different things. You own your own company and then you teach at the school for architectures. What does a typical day look like for you? I'm sure it varies like day to day.
So right now we're in the summer session. So summer is a little different. So summer I teach every morning from 8 to 9:35. And right now it's all online. So I get on Zoom just like we're doing right now and teach the class. But they've already said that fall semester will be in person. So we'll see.
Oh, okay. So you guys
Usually
have made that
my
call
class
already.
has 120 students in it, and I think they're trying to limit class size down to 30 now. So we'll see
Okay.
how they figure that out. But right now, I usually get up at 5:30 and I go work out in the morning um, and listen to a podcast while I'm working out. Then get to work at about 7. Lots of emails got to respond to. Again, it's a lot of communication. Um, and then I teach that class from 8 to 9:35. From 9:35 to 10 is our coordination time here in the office. So if you've got questions to ask, that's usually when we try to fit those in there to make sure that all of our teams are on the same page here in the office. Then we try to do 10 to 12. We try to do as our focus time. So 10 to 12, we're focused on whatever task we have to get out. So usually for me, that's looking, all right, an architect has sent
Go
us a
ahead,
new
Drew.
project and they need a design fee. How much is it going to cost us to design that building? So I have to look at it. I have to calculate, well, how many hours are we going to have to spend on this design? And I'll tell them, that's going to be $50,000 is going to be our design fee for that project. So I have to send out those proposals and agreements, do a lot of that. And then we also do design. I still do design from time to time, not as much as I used to, but most of the stuff is on the computer. And I'll try and swing around if you don't get sick here, but I'll show you my desk setup. So
Oh, you
we
have so many screens.
they're not all black, but yeah, we do a lot of stuff on the computer, and we usually have a lot of different programs
Wow.
open. So we'll be using all of these screens. Um, so that's a big part of what we do. In fact, just to show you, I've got a set of paper drawings here, which is probably what most people think of, but this is very rare. And the only reason I have these printed out is because this job was from 1962, and it doesn't load very well when you're looking on PDF. So pretty much everything that we do is on the computer nowadays. Lots of email. One of my students said that she thought that email was antiquated. I was like, well, I don't know who gave you that advice, because I probably send about 100 emails every day. Like in business, we're not Snapchatting each other. Some people do text message, but we prefer email. Email and phone calling, the traditional stuff is still what rules the day. Not many faxes going out these days, but yeah, a lot of email and phone calls.
Okay. Oh, so we do have like a nice mix of different kind of things that you're doing. And something is brought up though that everything's on the computer, and probably a misconception some people have about architects too, is that like the idea of drawing, that you need to know how to draw so that you can draw out these expansive buildings, different things, but maybe not necessarily, because you can just use a computer program to do that kind of stuff.
Yeah, so you'll see the gap. So pretty much any architect over the age of 50, they still do lots of hand drawings. The architects under the age of 30, they're pretty much doing everything on the computer because we have 3D software programs now. I should have pulled it up before we got on here, but they can make that building in the computer program look exactly like it's going to look when it finally gets built. And that's a huge advantage from our side, from coordination, because we can look at it, make sure we're designing it correctly, but also for the owner, because they can virtually look at it before they actually tell the construction guy to break ground. Because it's a lot cheaper to make changes when it's still in design than when it's
Right.
already out there in the real world.
That probably also, like, as an industry, has saved time on how long it takes for designs to being doing it on a computer versus having someone who has to do it by hand and making sure they're measuring it, that the scale is right and all of that stuff, because you can just do all that on a computer automatically.
So that's a big topic in our industry, and it comes down to, we've got all this great technology. Why, as an industry, are we not so much more profitable, right? Because we've got this amazing technology, but the easiest example I can give you that is the complexity of buildings has ballooned with the technology. So
Yeah.
at my previous company, we were the original engineer for the Astrodome, which at its time when it was built in the 60s was the eighth wonder of the world, a big deal, right? There is a total of 9 structural sheets for the Astrodome. Comparatively, Kyle Field, which was built in 2014-15, has about 200 structural sheets. So it's a smaller size
So
building.
what are structural sheets that you're talking about when you say that?
So it would be like these sheets. Like how many sheets of these are required for that project, or
Okay, got it.
drawings? Like the kind of the more layman term would be blueprints. because
Okay.
that's what to call them. But yeah, so how many drawings are there to show the contractor how to build it? Now, if I had to relay it, has anybody ever put together an IKEA furniture, right? You've bought something from IKEA, so you have to follow the manual. How do you put this thing together? That's basically what we do for buildings. We put together instruction manuals for how do you build this building, so that it's safe and doesn't fall down. But yeah, so Astrodome, 1968,
So
eighth
you
one.
come up with the structure on how to put it together.
Yeah, yes. It's the simplest way I can say it.
No, I mean that's a good analogy and it makes sense. And you're saying that even though like something as big as the Astrodome, it only took 9 sheets, it's 200 sheets for something today because of the complexities of all the technologies and stuff we have. And I guess as we continue to move forward, because now we think about like solar energy and making homes more energy efficient and all those things come into play as well when you're putting buildings and stuff together as well, that adds to complexities, right?
Yeah. Well, and to the big thing right now in architecture and engineering is resiliency. So we're trying to build resiliency into our buildings, which means that they don't sustain as much damage when they're flooded or there's a hurricane or an earthquake. Because right now, the building code, the minimum, if you follow the minimum requirements of the building code and you have a hurricane that hits your building, that building is going to be severely damaged. Now, it won't collapse, so you save the life safety of the people inside, but your windows are going to be blown off, your shingles are gone, so it costs a lot of money to replace that. Requires a lot of new material. So that's kind of the thing we're looking at now, is how do we build that resiliency, so it can take those hits and still be standing.
Yeah. Wow. I guess, like, I mean, over time, as you know, more disasters and things happen, we learn from them, and then we have to put those into place to see what we can do to not make those things happen as much as we can in the
Yeah.
future.
And we do, yeah. That's kind of the good thing about the industry. We do learn from every disaster. So every new hurricane, there'll be new code requirements that come out, that we lessons learned, like what didn't work, what did work, and let's proceed forward with what worked and try and fix what's not working.
How often do the codes change?
Every 3 years.
Okay.
So it's called the IBC, the International Building Code, which is pretty much used everywhere in the United States. But it's thanks to that 10th Amendment, right? So everyone knows what the 10th Amendment is, right?
What's the amendment?
The 10th Amendment. So, like, the 10th Amendment of the U.S. Constitution, basically it said that anything not is explicitly in the Constitution goes to the states, right? States' rights is what the 10th Amendment is. So
Mm-hmm.
what that means is that every state can adopt their own building code, because there's not a national building code for the United States. So every state, and even break it down even more, every city can adopt their own building code. So if I design a building in the city of Houston, it'll have a different building code than if I design it in Dallas or if I design it in Chicago. Now, the differences are usually fairly subtle. They're not that big of a difference, but they do make changes from city to city. So we do have to pay attention to that. But that international building code, which is kind of like the master code, it changes every 3 years.
Okay. But I think it makes sense too that, like, I guess from city to city, some of the things will be different because they think about like weather and all of that stuff.
Mm-hmm.
Someone in things buildings in Chicago have different needs than like in Texas where we don't have hurricanes and tornadoes per se, like in the city of Chicago, and that's something that's real we have to think about in Houston or Dallas or something. So
Yeah, it's a good example. So, like, the city of Houston has said you don't need to worry about snow loads. So
right.
when snow falls on your roof, it can be a problem. It's not a problem in Houston. But we just did a project up in Baltimore, and they require you have to design for a minimum snow load of 40 pounds per square foot, which is a lot of snow. It's about 8 feet of snow that you would have on
Wow.
your roof. So yeah, there's good reasons why the code needs to change a little bit when you go from jurisdiction to jurisdiction.
Yeah. Nice. So interesting. Like all the my mind's kind of blown right now because I'm learning so much about this work that I didn't know anything about. Engineering is so cool, and more people need to get into this field and do this work.
Well,
Um,
I'm sure you could blow my mind on the world of mentoring young people too. We all have our expert qualities.
that's true. That's true. So, where do you see yourself in 5 years? What's coming up down the line for you?
So, as a company, every year we put out a vision statement. Where we want to be. So, in 5 years, we think that we're going to be at about 70 to 80 employees. and grow. Like this year, we're going to do about $2 million in revenue, and we'll think that we'll be doing close to about $15 million of revenue then. So that's where we want to go as a company. So for us to get there, that means I have to grow as a manager and as a leader, learning how to delegate better, leading a group of people, because we've all got to get on the same vision in order to have that kind of substantial growth that we're trying to get. On a personal level, my wife is pregnant with our second child, so we've got a little boy coming. So we're excited about that.
Congratulations. Babies are always blessing.
Yeah. Trying to think what else. 5 years, I plan to still be teaching at Texas A&M. I really do love teaching, not only because I like engaging with the students, but I also think it makes me a better engineer, because when I am teaching to architecture students or construction students, I have to break it down very simply. And in order to break down something very simply, you've got to understand it really well.
Yep.
So what I always tell our guys is, if you can't explain a concept to your grandmother, you don't really understand it.
Mm-hmm.
But
Yep.
yeah, if you can explain it to your grandmother, you've got a good grasp of it. You can break it down to its simple aspects.
Nice. So, what piece of advice would you think you would give to your younger self, knowing what you do now?
So the one thing, when I was at Kansas, my sophomore year, I tore my labrum on one shoulder. I had a torn AC joint on the other, and I also broke a rib, all in one football season. And I kind of remember that I kind of lost my love for football because I kept playing, but it hurt. Like, every time I would hit, it would really hurt. And I think I lost my drive, the same drive that took me from being on the sophomore B team to being an all-state football player. And so if I was going to go talk to my sophomore self, I would tell myself to suck it up and like never lose your passion. Or if you're not passionate about something, get out. So that's kind of a lesson learned that I take into my career. One, don't get burned out, because that's basically what happened. I got burned out because I was hurt. And you'll hear it from a lot of former athletes. It's the injuries that can get you. But I wish that I had battled through it. It's the mental thing. It's mental. It wasn't physical. It was mentally. I got burned out. I lost my love for the game, so to say. So I stopped trying as hard. And that's a lesson learned that I wish that I could go back and tell myself not to do that.
Okay, that's valid. So I'm actually gonna go back a little bit, because you are a professor, and you do teach, so you're always seeing new talent. Have you ever hired any of your former students to work with you, or are you ever like keeping your eye to see if you see potential talent that can work with you, and knowing that your next 5 years you're planning to like quadruple your company? Is that something that you're doing or have thought
Yeah.
of?
So I wouldn't be a good leader if I'm not doing that. But they're not my employees, because I teach architecture and construction science students. So they're my future clients.
Got it.
But
Okay.
yes, I mean, I've already had students. Scott, I've been doing this for 7 years now. So I've had students that are now clients of ours,
Nice.
because they remember me. They liked me as a professor. They thought I was good. So they reach out to me whenever they need help for structural engineering. So we've been able to do that. Now, yeah, I would like to get into the College of Engineering. So I can cherry pick, the best students every
Yeah.
and bring them on over. Yeah, interviewing somebody is hard. Being able to break down somebody's true character in a 1 hour conversation is a difficult task. But I can guarantee you, if you give me a semester with somebody as a student, I can tell you whether or not they're a hard worker. And that's the thing we look for the most: attitude, and are they a hard worker? I don't really care that much about your GPA. The IQ is not going to be that differentiator, but do you work hard and do you have a good attitude? Those are the big ones.
Yeah, that makes sense. So, what piece of advice would you give to someone who's looking to possibly go into this field in the future? Like, it's a high school student right now.
I would tell them, so you don't have to be a math whiz to get engineering. That's a misconception that I hear a lot. Now, we do have to take some tough math courses, but really you just got to get through them, because I had to take calculus 1, calculus 2, differential equations, advanced calculus, and all in college. And I don't think I've used any of that. since I've been working. There's a difference between somebody that's in academia and you need to know kind of that higher order math, and people that are in practice. We have computer programs that do it for us. So that would be the one thing I would say. Don't let it discourage you if you're not an ace in math, because once you get into practice, it's not a huge limiter there.
That's a big one because I'm sure a lot of people are think like you think engineering, you automatically think, okay, math. I have to be really good at math. So that's a really big one.
Yeah, well, I'll tell you, still 85% of success in my field is, can you communicate with people? Can you lead people? Can you manage people? 15% of it is probably the technical side. Can you do the math? Can you think on your feet? But yeah, still it's the people skills that matter.
So in addition to like the people skills, what are other skills that are essential in your job?
Hmm. So the one thing is we survey all of our clients, usually twice a year. We'll take them out to lunch and just ask, what are the three things that you like that we're doing? What are the three things that you think we could work on to get better? The number one trait that pretty much every client always talks about is communication. Do you communicate effectively? And a lot of times it's as simple as, do you return their emails in a timely manner? You're not waiting a week later to be like, oh yeah, I'll get you that. So communication is a skill. And again, this is another one. So I always knew kind of in college I wanted to be in engineering. So I had to take writing classes. I had to take English classes, and I blew them off because in my mind, I'm an engineer. I don't need it. Like, I know how to write, but I don't need to know how to write really good. Again, I would kick myself because I spend most of my time writing. I'm writing either structural reports, I'm writing agreements, I'm writing emails, I'm talking on the phone. So yeah, I I guess when you're in college, when you're young, you think it's all about the technical side, and you don't really think so much about the soft skills that you need. But yeah, I wish I had paid more attention in my writing classes.
That's valid. That's good. What do you think the biggest challenges are that you face in your line of work?
Hmm. Well, one of the biggest challenges is we are a global industry now. So we compete with people from China, India, South America. And I would say it's a good thing. It's kind of a current challenge because it's relatively new, that the market has opened up like that. But I think in the end, it's going to be good because it's going to make us better if we're having to compete. And so the main difference is the base salary for one of my guys starting out is usually around $65,000 a year. And a firm that's operating out in South America, they're paying people $15,000 a year.
Wow.
So there's a huge salary, and we're doing the same work. So how do we still convince the client that we have the value when they can get it much cheaper from somebody else, in South America or India? So that's a pressure. I mean, but pretty much every industry is facing that nowadays, that global pressure.
Yeah. Yeah. That is it's well, I guess, and I have a question about that too, because like you said, like it's international, but do other countries have, like, when we're talking about codes and all that stuff, like if you are using someone who, for example, is based in South America, are they going to be able to know like what the codes and requirements are to do work here, knowing
Yeah,
like, how the codes and stuff are
and I would
different?
say generally not as well. I mean, they could. What a lot of the larger companies in the U.S. have done is they set up satellite offices in India or South America,
Okay.
and that way they still have guidance. They have somebody here that understands the local codes better, but they can take advantage of that cheaper labor in those other markets. But like a firm my size, we don't have the resources to go set up an office in India. So right now, that's something that only the big companies can do.
True. Sorry, you just broke up a little bit on that last piece.
I was saying that when people setting up these satellite offices in other countries, like a 15-person small business like mine, like we can't go do that. We don't have the resources to set up something like that. But so right now, it's the advantage of the larger companies, the companies that have 1,000 employees. they'll go set up these satellite offices. We can't do that right now, but we are seeing that pressure.
Okay, that makes sense. That makes sense. Well, I guess just wrapping this up, is there anything that you wish you would have done to better prepare yourself for the work you're doing right now?
I've already kind of spoken about it, but I would still go back and I said I wish I would have paid more attention to like my writing intensive courses. Yeah. And I hear that from a lot because I talk to a lot of professionals and a lot of, I talk to accountants and architects, and a lot of people will kind of echo that same sentiment, that we kind of blew it off when we were in high school and college because that's not what I wasn't going to be a poet or an author. But in fact, now I am writing a book, so I will be an author. And now I'm like, I really wish, because now I don't know where that comma goes. I have to ask my wife to review it so she can tell me where my commas need to go.
I think so. Part of that too is that when you're in school, you're learning so much, so it's hard for you kind of like to filter, knowing, okay, I'm not gonna know how to, I'm not gonna have to know how to solve a polynomial equation later, but I'll use a comma. I should stick that in the back, right? Because so much knowledge is coming at you, so you don't know what's going to be useful later. So that is some great advice to have people who are still in school right now to know what to pay attention to. Like we really pay attention. Advice. Drew, we're going to go ahead and wrap it up. I want to thank you for taking the time to speak with us tonight about your background and the work that you're doing, your experience as an athlete. I'm sure you being a Jayhawk, you'll probably be a connection since at Trey, we have a few Jayhawks on our staff. So thank you so much for giving us your time tonight. We hope that you'll be willing to do some additional work and volunteering with us as we continue to build out our organization. And to everyone who was able to join us tonight, we thank you for spending some time with us. We hope you learned some stuff from Drew. I definitely did, and I have so much appreciation for engineering, and I've learned even for building. So thank you for the work that you do, Drew, and keeping our building safe so that you don't have to think about it.
Yep, my pleasure.
Great. Well, to athletes everywhere, this is brought to you by Trey. Good night, everyone.
Bye.